We've been given a function, f of x, and we've been told that x minus 4 is a factor of f of x. We need to show that 16p plus q plus 8 is equal to 0. So given that x minus 4 is a factor, the factor theorem tells me that that means that when I substitute 4 into the function, I will get 0. So that's exactly what I'm going to do. I'm going to substitute 4 in instead of the x. So I will get 4 cubed plus p plus 1 times 4 squared minus 18 times 4 plus the q will be equal to 0. 4 cubed is 64. 4 squared is 16. The minus 18 times 4 is minus 72. And we've got the plus q. I'm just going to expand those brackets now. So we'll have the 64 plus 16 times p plus 16 times 1 minus the 72 plus the q is equal to 0. The 64 plus 16 is 80. Minus the 72 is 8. We've got the 16p still there, and we've got the plus q still there. And now just comparing to what I needed to show, we can see we have done part A of the question. These are identical statements, so part A is done. Part B, we're told now that x plus p is also a factor. We've also been told that p is greater than 0. So I'm going to use the factor theorem again. This time, if x plus p is a factor, that means that when I substitute minus p into the function, I'll get 0. So I'm going to substitute minus p here, here, and here. So I'll get minus p cubed plus p plus 1 times minus p squared minus 18 times minus p plus the q is equal to 0. Right, simplifying that. The minus p cubed, so minus p times minus p times minus p will be minus p cubed. Next, we've got the minus p squared, which will just be a plus p squared, because minus p times minus p is plus p squared. We've then got the minus 18 times minus p, which will turn into a positive 18p. Expanding these brackets here. The p times p squared is p cubed. The 1 times p squared is p squared. And now notice that the minus p cubed plus p cubed is going to cancel each other out. So I'll just be left with p squared plus 18p plus q is equal to 0. And now just comparing to what we needed to show, we've done it. So that's part B done. Right, part C, it says hence find the value of p and the corresponding value of q. So we need to solve these two equations simultaneously. Lots of different ways we could do this. I'm going to make q the subject of this first equation. So I'm going to subtract the 8 and the 16p from both sides. So q is equal to minus 8 minus 16p. And then I'm going to substitute my q here into the second equation. So we're going to have p squared plus 18p. Then we've got the minus 8 minus 16p is equal to 0. The 18p minus 16p is 2p. We can now factorise that quadratic. And finds that p is either minus 4 or p is 2. But the question did tell me that p was greater than 0, so I can ignore the negative 4 solution, and I know that p is actually 2. Now I know p is 2, I can work out what q is going to be by substituting the p in. So q is going to be equal to minus 8 minus 16 times 2. So minus 8 minus 32 is minus 40. So that is the corresponding value of q. And that is part C of this question done. Part D then says to factorise f of x completely. Because we now know what p and q are, so I'm going to take this function down here and write it out now I know what p and q are. So f of x, we've got the x cubed. Now previously I had a p plus 1 x squared. We know that p is 2 now. So 2 plus 1, we've got 3x squared. We had a minus 18x, and we had a plus q, which we now know is minus 40. So that's my f of x with all of the coefficients known now. We need to factorise this. Well, remember we do know two factors already. We know x minus 4 from part A of the question. And we also know x plus p from the second part of the question. And we know that p is 2. So x plus 2 is a factor as well. The only thing we need to find now is the third factor. Now, we could do some algebraic division if we wanted to, or we could just look at this really carefully. We've got x times something, which is going to give us the x cubed. That's just going to need to be a single x. X times x is x cubed. Now I'm looking at the constant numbers. We've got a minus 4 times 2 times something, which is going to give us the minus 40. Well, the minus 4 and the plus 2 would multiply to make minus 8. So that's going to need to be multiplied by a positive 5. In order to get the minus 40 that we're expecting on the end there. So that must be the third factor, x plus 5. And if you wanted to, you could always expand that out and prove that this is the same thing as this. But that is f of x in its factorised completely form. That's my answer to part D of this question.